This video is about definition 4 of Euclid's volume 1, stating a straight line is a line which lies evenly with the points on itself. So the origins of this definition, or Euclid's definition, is Plato. Plato's definition states that a straight line is that of which the middle covers the ends, meaning if a person were to view a straight line from one of its ends, then there would be no sharp turns or anything like that. So if a person were to view a line in a plane like this from one end of it, their vision would look like this. There's just one point. However, if the line was not straight, the person would view it like this and they would see movement in the line. And while this definition does make sense and it's heavily referenced, especially by Euclid, it does involve sight, which is a physical property, and therefore it has to involve a postulate also that the line of sight itself is straight. For Euclid's definition, he sought to remove this physicality and define it in as basic terms as possible. Proclus further defines it from Euclid's definition without the eyesight by stating that the straight line alone of all lines occupies a distance equal to that between all the points on it. So in diagram, a straight line would have a distance covered by the 2 points on either end to equal to that of the line itself. However, if a line was not straight, the distance covered would not be equal to the direct distance, the shortest distance possible between the two lines. This would help counteract the involvement or the inclusion of a circle in a straight line, because a circle is a continuous line. However, the distance that a circle covers between its two lines is not equal to the physical distance between the 2 points by which it is formed, because they're so close. This also, however, this includes the notion of distance, notion being another definable term that Euclid sought to eliminate in his definition. So according to Flatterer, Euclid's definition was actually seeking of doing something impossible, because it sought to not include any notions, any physicality, and it needed to also be understandable without drawings, without a physical diagram of it, which it did achieve. Another proposition by Euclid is that part of the line cannot be in the assumed plane while part of it is in one higher up. So very clearly, if a line is obviously not straight like this, you can tell that the 2 planes drawn are different planes. However, what if the line was like this, where the 2 planes are above and below, and that line obviously looks straight? This could be a misdirection, because for a line like this, the assumed plane would be that between the 2 lines themselves. While it's a diagonal to us viewing from up top like this, it is still an assumed plane, and so his definition holds true.